Hello friends, today we're going to start talking about factoring polynomials. Specifically, today we're going to talk about factoring polynomials by finding the greatest common factor, which we call GCF. So recall, to find the greatest common factor, we find all the factors of the numbers. Greatest means biggest, common means it's in both, factor means it's a number you multiply to get to it. We're going to find GCF by finding the prime factorization. So 15 is the same as 5 times 3. We can't break that down anymore. There's no numbers that multiply to 5 except 1 times 5. There's no numbers that multiply to 3 except 1 times 3. So the prime factorization of 15 is just 3 and 5. If we look at 90, there's many ways we can get to 90. I know that 90 divided by 2 is 45. So I'm going to say 2 and 45. 2 is prime, so I can't do anything else with that side. So I'm going to continue breaking down 45. We can't divide 45 by 2, but we can divide it by 3. And it's 3 times 15. 3 is prime, so I can't do anything else there. And 15, as we just said, is 3 times 5, which are both prime. So 90 ends up being 2 times 3 times 3 times 5. So I want to take out anything that's common, and it looks like both a 3 and a 5 are common. So our greatest common factor then is 3 times 5, which is 15. Let's look at 26 and 39. I know I can divide 26 by 2. It's 2 and 13. Those are both prime, so I can't do anything else with 26. It's just 2 times 13. Looking at 39. 39 is not divisible by 2, so I'll go on and divide 39 by 3. And I get 3 and 13, which are both prime. We can't do anything else with those. So 39 is 3 and 13. So now the GCF here, the only thing that's common to both is 13. So our greatest common factor is 13. Let's look at it with polynomials. Let's break down our 8 first. 2 times 4 gives me 8. 2 is prime. 4 I can break down into 2 times 2. And that x will just add on at the end. So the prime factorization of 8x is 2 times 2 times 2 times x. And then looking at 4, 4 is just 2 times 2. Those are both prime. We can't do anything else with those. So 4 is just 2 times 2. Our GCF then is anything that's common to both. Which is 2 times 2, which is 4. So the GCF of 8x and 4 is just 4. Let's look at 15x squared and 18. 15, we've already said, is 3 times 5. There's nothing else we can do with that. We can't break those down any farther. So 15x squared, 3 times 5 times x. 18 then, I know I can divide 18 by 2. It's 2 times 9. 2 is prime. 9 can break down into 3 and 3. So 18 then is 2 times 3 times 3. Looking for anything common, the only common thing I see here is 3. So the GCF of 15x squared and 18 is 3. Let's look at 6x squared here. Again, we'll just do the x squared at the end. So 6 I know is divisible by 2. It's 2 times 3. Those are both prime. I can't do anything else. So 6x squared is 2 times 3 times x times x. Looking at 9x, the only way I can multiply to 9 is 3 and 3. We can't go any farther with those because 3 is prime. So 9x then is 3 times x. Looking for anything common, I see a 3 and an x in both of these. So our GCF then is 3 times x, which is 3x. Let's do some more here. Looks like we have some trinomials. We'll start with 12x to the 5th. I know I can divide 12 by 2. It's 2 times 6. 2 is prime. 6 can be broken down into 2 times 3. So 12x to the 5th then, 2 times 2 times 3. And then we have 5 x's. Let's look at 8x to the 4th. I know I can divide 8 by 2. It's 2 times 4. 2 is prime. 4 can continue to be broken down into 2 times 2. So 8x to the 4th then, 2 times 2 times 2, x, 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 x. Make sure you have 4 x's there. And then finally, 6x to the 3rd. 6 is 2 times 3. Those are both prime. So 6x to the 3rd is 2 times 3. And then we have 3 x's. So let's find everything that's common. The only number that's common to all of them is a 2. 8x to the 4th doesn't have a 3, so I can't use 3. And then it looks like we have 3 x's that are common to all of them. So again, I'm circling things that are common to all 3 terms here. So our GCF then is 2 times x times x times x, which is 2x to the 3rd power. Let's look here. We're going to kind of just ignore the negative for now and just split apart the 18. I know 18 is 2 times 9. 2 is prime. 9 is 3 times 3, which are both prime. So negative 18y to the 4th. Let's just put a negative. And then we have 2 times 3 times 3. And then we have 4 y's. 6x to the 3rd. 6 we said is just 2 times 3. We can't break that up anymore. So 6y to the 3rd. 2 times 3. y. 24y to the 2nd. I know I can divide 24 by 2. It's 2 times 12, but 2 is prime. 12 then is 2 times 6, and 2 is prime. 6 is 2 times 3, which are both prime. So 24y squared, 2 times 2 times 2 times 3 times y times y. So looking for anything common, it looks like all of these have a 2, and all of these have a 3, and they all have a y times y. So our greatest common factor then, 2 times 3 times y times y times y, which is 6y to the 3rd power. All right, the last part we're going to do here is actually take out the greatest common factor and then put in parentheses everything that's left. So it's kind of the opposite of multiplying polynomials. It's really not a huge difference from what we were doing before. So let's look here. X doesn't have any coefficient, x cubed. A coefficient would be something that's in front of the letter. We don't have anything there, which means x to the third power is just x times x times x. 5x squared, the only way to get to 5 is 1 times 5. 5 is already prime. We can't really break it down any farther. So 5x squared is just 1 times 5 times x times x. Up here we could say this is 1 times x times x times x. And then 22x. 22 is 2 and 11. Those are both prime. We can't do anything else with those. So 22x is 2 times 11 times x. So we start out the same way here. We find stuff that's common to all of them. The only thing I see that's common to all three terms here is 1x, not 2 x's, there we go. 1x is the only thing common to both. So whatever the GCF is now, we put on the outside of the parentheses. The inside of the parentheses is the leftovers. So if I put my x on the outside of the parentheses, what's left over in green here is just x squared. Because we have a plus there, we'll put a plus here. What's left over in pink is 5x if I multiply all of those together. Since this is a minus, this will be a minus. And what's left in purple looks like 2 times 11, which is 22. So this now is our final answer. The GCF went on the outside, whatever was left over went on the inside. So get a couple more here. 16, remember we're gonna ignore that negative for now. 16, 2 times 8, 2 is prime. 8 is 2 times 4. Again, 2 is prime. 4 is 2 times 2. So negative 16, y to the 6, breaks down into 2. Actually, let's put the negative 1 out here first. Negative 1, and then 2, 2, 2, 2, y, 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 and y. Looking at 28, y to the 4th. I know I can divide 28 by 2. It's 2 and 14. 14 then is 2 and 7, which are both prime. So 28 y to the 4th is going to break down into 2 times 2 times 7. Then we have 4 y's. And then 20 y to the 3rd. 20 is 2 times 10. 2 is prime. 10 is 2 times 5, which are both prime. So 20 y to the 3rd, 2 times 2 times 5, y, y, y. So now, looking for our GCF here, it looks like they all have 2 2's and 3 y's. So our GCF, 2 times 2 times y times y times y, gives me a GCF of 4y to the 3rd. So now everything that's not circled goes on the inside. So So we have our 4y to the third on the outside. If we look at our negative 16y to the 6th, what's left over here? Let's look at what's left over. We have a negative 1, a 2, a 2, a y, a y, a y. And if I put all those together, I would get negative 4y to the third. Same as our GCF, it looks like. Since this is a plus, we'll have a plus here. Let's look at what's left over in purple. Looks like it's just a 7 and a y. So 7y. Since we have a subtraction here, we'll do a subtraction here. And what's left in orange is just a 5. So this is our final answer. Again, the GCF goes on the outside. Whatever's left over goes on the inside. Let's look at one more example. All right, we have x's and y's here. 16 we just did over here. We said 16 is 2 times 2 times 2 times 2. Started out as 2 and 8, broke it down to 2 and 4, and then 4 was 2 and 2. So negative 16 xy squared, negative 1 times 2 times 2 times 2 times 2 times x times y times y. Only the y is squared, not the x. 4 is just 2 times 2. So 4x squared y, 2 times 2, x times x, and y. And then 8xy. 8 is 2 and 4. 4 is 2 and 2. So 2 times 2 times 2 times x times y. For 8xy. Looking for commonalities here, I see 2 2's in each. I see 1x in each, and I see 1y in each. So our GCF then, 2 times 2 times x times y, which will give us 4xy. Again, that goes on the outside, and anything left over goes on the inside. If I look at what's left over in blue here, I have negative 1, 2, 2, and y, which all would multiply to give me negative 4y, plus what's left over in purple is just an x, minus, again, because this is a minus. What's left over in red is just a 2. So this is our final answer. I should tell you, with all of these, we can use the skill we learned last unit of multiplying through. When I multiply all of these by x, I should come up with my original problem, x cubed plus 5x squared minus 22x. Same thing here. If I multiply all the terms by 4y to the third, I'll end up with negative 16y to the 6th plus 28y to the 4th minus 20y to the third. Here, if I multiply everything by 4xy, I should be left with negative 16xy squared plus 4x squared y minus 8xy. Alani is in charge of marketing for a travel company. She's designing a brochure that will have 6 photos. The photos can be arranged on the page in a number of ways. There are 2 main square photos which have a length of x on each side. There are 4 narrow photos that are each 1 by x. same here, 1 by x, 1 by x, and then this is x by x. So what is the total area of all of the photos? This is actually easier than it seems. The area of this is x times x, or x squared. This is 1x. 1x, I'm just multiplying the two sides like we did last unit. 1x, 1x, and then this is x squared. So the total area, x squared plus 1x plus 1x plus 1x plus 1x plus x squared, which gives me a total area of 2x squared plus 4x inches squared. We need to make sure to label. All right, friends, have a nice day.